Hello guys and welcome back. So this is the second video on this section. We are looking at integration by substitution, which is part of the integral technique. Okay, and this is the first one we are looking at. So this is the second video. In this video we're going to be solving some more questions. Okay, so it's a continuation of what we did in the last video, so go ahead and check it out if you haven't already. So this is what we have. We'll start with this question. We are asked to integrate this function. Now, unlike the previous cases where all the examples we treated were involving fractions, now we don't have fractions. These are all products. So when you have a product like this, what do you actually do? Which of them will you assign to be a u? Now you have 2x plus 1, you have x squared plus 4 raised to the power of 4. Now basically you should always look out for the term having a power. Okay, that's what you should look out for. But that's not always going to be the case. Okay, I have one example that is going to show you that. But for this, we are going to look out for the term having the power, which means we assume that what we have here should be the value of u. So we take the value of u, we say u should be equal to x squared plus x. That's what we have u to be. Now since u is x squared plus x, what we need to do next, as usual, we differentiate u to see what we are going to get. So let's differentiate u. So if we differentiate u, meanwhile before I do that, let's create a line here. So if I differentiate u with respect to x, what I should be having for this will have 2x, and this will give us the result as 1. So we have 2x plus 1. So from this you can cross multiply. Du is going to give us now 2x plus 1, right, being multiplied by dx. That's what du is. So here you can make dx or a formula. Making dx or a formula, you divide both sides by 2x plus 1. Your expression is going to be du all divided by 2x plus 1, right? So since this is what we have now, we need to pick this and substitute into this expression. So if we substitute into that expression, now we are going to be having the integral of our 2x plus 1 remains. This is 2x plus 1. Then in place of x squared plus x, what we have now is u, but now it is raised to the power of 4. For that reason, u is going to be raised to the power of 4. In place of dx, what we have now is du all over 2x plus 1. So there, that's going to be du all over 2x plus 1, right? So now 2x plus 1 will cancel out 2x plus 1. What we have is just the integral of u raised to the power of 4 with respect to u. So if you integrate u raised to the power of 4, what you're going to get is u raised to the power of 5. Right, that's a 5, then you divide by 5, and then you have your plus c. So that's the result we have. But you can't leave your answer this way, because who knows the value of u? You're the one that substituted a value for you, so you have to replace that value. So in place of u, we have x squared plus x. So that's going to be x squared plus x raised to the power of 2. But remember, this is divided by 5, so we divide this by 5. I'm going to do it this way for the sake of space. Then we have plus c. So that's the answer to this first question. The integral of 2x plus 1 x squared plus x raised to the power of 4 dx is equal to, this is power of 5. I wonder why I'm writing power of 2 here. So I need to wipe this and include and make that a 5. So this x squared plus x raised to the power of 5. This is a 5, right? Yeah, that's my 5. So let's see the next question. So this, we are pretty good to do the same thing pretty much. So we have to pick the term having a power. Let's have this division. So this is term having a power, so we say let u be that term having a power, so it becomes x cubed plus 100. That's what we have. So we differentiate with respect to u. Du dx becomes, this is going to give us 3 x raised to the power of 2, this is a constant, so that will become 0. Cross multiply, du is going to give us 3x squared dx. So you try to make dx squared formula by dividing both sides by 3x squared. So dx is going to give you du all over 3x squared. So you substitute into this expression now. What you're going to have, this implies that you'll be having 3 times of x squared times everything here is u, so we are going to raise u to the power of minus 2. In place of dx, I have du all over 3x squared, so that's going to be du all over 3x squared. So 3x squared and 3x squared will cancel. We have integral of u raised to the power of minus 2, so this is going to be the integral of u raised to the power of minus 2 times du. So if you integrate u raised to the power of minus 2, that will give you u raised to the power of minus 2 plus 1, remember, there you have your plus c as usual. Minus 2 plus 1 will give us minus 1, and u raised to the power of minus 1 plus c is what we have. But remember, u raised to the power of minus 1 can also be expressed as 1 over u, then we have a plus c. But in place of u, we can put the value of u, and if you see, the value of u is x cubed plus 100, so this becomes x cubed plus 100, and all of that, we have a plus c somewhere. So that's for the second question. We have our result with 1 over x cubed plus 100, which is the same procedure as the other one. Now let's see something that is a little bit different. Now the reason I'm saying this is a little bit different is this: we have this expression. Now we may ask, what should we use as the value of u? Should we, as usual, go ahead and pick the term that is having the power? That means, say, in this case, based on what we've been doing, that let's make u to be equal to sec x, because that's pretty much what we've been doing in all other cases. Should we make u to be sec x? Now once you do that, this is not going to work out. Okay, the reason it's not going to work out is when you differentiate this, you're going to get du, you're going to get sec and tan, right? Sec x tan x, that's what you're going to get. When you go ahead and substitute, that's going to give you an expression you may not like. Okay, it's going to give us, basically, to give you an expression you won't like. So don't bother trying to use u to be equal to sec x. That's all I'm saying. So in this situation, what we are going to do is we are going to make u to be tan x, because that's actually going to solve out the equation. If you differentiate tan x, you're going to get sec square x, which means eventually sec square x gets cancelled out. Okay, so this is a no. We say no to this. We are going to say u should be equal to tan x in this case. So if u is equal to tan x, differentiate u with respect to x. If I differentiate tan x, what I will get is sec square x, cross multiply, du becomes sec square x, sec squared x dx. That's what you will give to you. Okay, so make dx a formula. Dx becomes du all over sec square x. So if I substitute into this expression now, what I'll be getting is the integral of, in place of tan x, I still have tan x, that's tan x. In place of sec square x, and that is a mistake, tan x is being replaced with u, so I need to wipe this. So in place of tan x, what I have now is u, so I'll say this is the integral of u. In place of sec square x, I yet have sec square x, so this is going to be sec square x. Okay, in place of dx now, what we have is du all over sec square x, so this will be all divided by sec square x. Now sec square x will cancel sec square x, and we are going to be left with the integral of u with respect to u. If you integrate u with respect to u, you're going to get u squared all over 2 plus your c. But remember, the value of u is tan x, so this is going to give us tan x all raised to the power of 2 divided by 2 plus c, which you're most commonly going to see as, instead of just tan x squared, you're going to see it as tan square x. That's how it's pronounced, all divided by 2 plus c. So that becomes your result to this question. Okay, that's the result to this question. So let's see something a little bit different that's going to give us something extra to work with. So now we have this. The question becomes, which one should we still assign to be the value of u? So you can guess now that we should use what is within the square root sign. Okay, so let's do that using what's within the square root sign. So we say u should be equal to x plus 1. You can decide to say u should be equal to the square root of x plus 1 also. It doesn't matter, I think it will work out just fine here. So we differentiate u with respect to x. If I differentiate u with respect to x, my result will be 1. Cross multiply. If you cross multiply, in place of dx, you're going to have du. So they are the same thing. So anywhere you see dx, you have du. Anywhere you see du, you put dx. They are both correct. Now substitute into this expression. If you substitute, you're going to have the integral of square root of u times, this is going to be x plus 5. In place of dx now, what we have is du, because dx is equal to du, so this becomes du. Now this is a little bit different from all other cases we've been solving, because in other cases, after you must have done this, what you now have here, everything is going to be in terms of u. You won't have any term involving x. But here we still have a term involving x, so we need to look for a way to take away this x. So how do you do that? What you need to do is to go back to where you have the substitution, this part where we have the substitution. Now we are going to make x the subject of the formula. So we say x becomes the value of u minus 1, because we transfer 1 to the other side. So in the place of x now we are going to put u minus 1. Doing that now, this is going to be the integral square root of u. I can, for the sake of what we'll do next, I can make it u raised to the power of 1 over 2. That's square root of u. X plus 5. In place of x, I have u minus 1. Then plus 5, so that's what we have, plus 5. In place of du, I yet have du. So this would be the integral of u raised to the power of 1 over 2. So I still have u minus 1 plus 5 will give us plus 4, so this becomes u plus 4, right? So we're integrating with respect to u. So this is the expression we have, but we need to expand this. U raised to the power of half will multiply. Take note, this is having an invisible power of 1, so you can use this guy u raised to the power of half to multiply that, and the power gets added. 1 plus half will give us 3 over 2. Okay, then this will also multiply to this. So in the next, that's what we are going to be doing. So that expression, we've not yet integrated, we are just trying to expand. So this will give us u raised to the power of 3 over 2, right? Plus 4 u raised to the power of 1 over 2. 1 over 2. And you're integrating everything here with respect to u. So if you integrate u raised to the power of 3 over 2 with respect to u, you're going to get u raised to the power, remember you add 1 to the power, that becomes 5 over 2 divided by 5 over 2. Same thing here, if you integrate this, you add 1 to the power, that becomes 4 u raised to the power of 3 over 2 divided by 3 over 2, then all we have plus c. So simplify this 2 will go to the top. You have 2 u raised to the power of 5 over 2 all over 5. Okay, take this 2 to the top also. That becomes 8 u raised to the power of 3 over 2 all divided by 3. Then as usual you have your plus c. So the next thing you guys have to do for me is this. We need to replace the value of u by substituting x plus 1. So go ahead and substitute that, and then you get the final result. So that's where we're going to end this video, guys. And as usual, guys, I'll see you guys in the next video, where we're going to be looking at another technique of integration. For now, I don't know. It might be integration by partial fractions or integration by parts, but I'll see you guys in the next video. Bye bye.